computer, what you need to do is to choose the initial values for Rk and the lambda, and then use any kind of numerical algorithm to solve for the minimum value for this function a, okay, and then update lambda. But right now, because I'm doing this on the blackboard or whiteboard, and I'm gonna use the analytical method to solve the problems for you， 可以吗？我再说一次啊，就是通常啊，我们是用电脑来算，所以你要直接先给它一个一开始的 lambda 跟 k 的值，跟 rk 的值，然后这样的话，它就直接就像是一个没有 constraint 的东西，你就用任何一个数值方法来解它的最佳化的这个问题。但是我们现在在白板上，所以我用手的方法来解 ，OK。So, anyways, do I have to write it down so that you can be clear about what's going on? Okay, yeah. So maybe I can just write it down more clearly. Okay. Yeah. If we solve this on a computer, yeah. Now we need to choose an initial lambda and rk and find minimum value of function a. Okay, yeah. So that's what we do on the computer. Okay, but over here on the board, I am just going to use I'm just going to take the derivatives. Okay. 对吗？我在这边，我在白板上，我就直接用那个用微分的方式来解了。OK。Yep. Yeah, but here we solve it analytically. Okay. Yep. So, what do you do? It's very clear that basically, since lambda and rk can be determined by us, then the real variables are just x1 and x2. So let's just take partial derivatives with respect to x1 and x2, okay? So let's just take partial derivatives, okay? I can't see that, but let me just directly write it down. Plus 2rk times x1 x2. Okay, yep. And take partial derivative with respect to x2. Very similarly. Okay? Yep. Yeah, I think this is very straightforward, right? We just take the partial derivative with respect to x1 and x2. Okay. And as usual, let's set this to be 0 in order to solve for x1 and x2. Okay? And after solving for x1 and x2, you will see that x1 is just 10 times rk minus lambda divided by 28 plus 10 rk. Okay? And x2 is just 4 times x1 Okay, so you can perform the multiplication. But anyways, after solving for the two equations, okay, let's say this is equation 1 and that is equation 2. Okay, so if we solve equation and combine equation 1 and 2, we can get the solution like this. Okay. And as I said, you will need to pick the original lambda and RK values. Okay. Of course, you can have you can just pick any arbitrary value, but usually, I have to say, usually R1 value, when k equals 1, okay, R1 equals 1, okay, and usually lambda when k equals 1, okay, lambda 1, maybe I should say that when k equals 1, usually R1 equals 1 and lambda k equals 0, okay, and then we will be able to update lambda k from here, and also usually, as you guys know, we will gradually increase the RK value, and usually each time we can multiply RK by either 1, by 2 or 5 or 10. Let's say over here we will multiply RK by 10, okay? 可以吗？因为就是 RK 的值，它就是在每一次 iteration 当 k 等于2的时候，它就是原本的 r 再乘上，你可以选择乘上2，或者乘上5，或者乘上10。我们这边选乘上10哈。Okay, so so now, as I said, now k equals 1, okay, and over here I have chosen R1 and lambda, okay. Yeah. So let's just plug in. Okay. So in this way, x1 equals what? X1 equals 10 times 1 minus 0. Okay. Yeah, it's very easy. 28 plus 10. Okay. Yep. So this is 2, 6, 3, okay, 3, 2, and x2 is 4 times that, so it's very easy. X2 is 4 times that, so that's 1.0526. Okay, so that's great. Now we have our x1 and x2 at iteration 1. Okay, so k is the iteration number. I already erased that. But anyways, k is the iteration number. Okay. Yep, any question? And then we also need to calculate h. Okay. So over here at iteration 1, what is h? H is, as you guys know, h is this, x1 plus x2 minus 5. Okay, so x1 plus x2 minus 5. So what do we have? We have negative 3.6842. Okay. Yeah. And by the way, this is h at the first iteration. Okay, so that's this value. Okay. And then I think we can just proceed, right? Because at k equals 1, I think we have got everything we need. Okay. And then when k equals 2. So when k equals 2, what do we need to have? Now we need to use the update formulas for the new lambda. Okay, I wrote it over here, but anyways, let me just directly write it down so that you guys remember. We update lambda in this way. Okay, lambda k plus 1 equals lambda k. That is lambda 1 plus 2 times r. Oh, by the way, over here let's also choose Rk or R2 to be 2 times 10, okay? Oh, no, sorry, yeah. It should be 1 times 10. Yeah, that is R1 times 10, okay? That is 10, okay? So, over here, Rk is R2 times H. Okay. So, that is when k equals 2, lambda of k equals 2 equals lambda k equals 1 plus 2 times R2 times H when k equals 1, okay? Yeah, anyways, I hope this is fine because we have just calculated everything, right? Over here, this is 0, and we have 2 times, what is R2? Yeah, R2 is 10, right? Times H when k equals 1 is that, okay? Yeah. So, what is this? Negative 7 point something, right? Okay. Yep. And then, with this value, so now we have my R2 value, and I also have my lambda 2 value. And then, we will be able to get my x1 and x2, okay? So in this way, x1 is what? x1 equals 10 times R2 minus lambda 2 divided by 28 plus 10 times R2, right? Okay, let me directly give you the number. So it is 0.A388, okay? And x2 can be calculated very quickly because it's just 4 times that, okay? Okay, so that's the end of the second iteration. And then, I hope you know how to proceed, right? Oh, and by the way, over here we also need to calculate h when k equals 2, right? It's very easy. That is just x1 plus x2 minus 5, okay? And you will see that it is negative 0.806. And over here, you can also quickly check whether everything looks alright. That is, our goal is that h should be close to 0. Yeah, it should be 0 or at least close to 0. And as you can see in the first iteration, h is far away from 0, okay? That is not very good. But as you can see at the second iteration, oh good, it's a lot closer to 0. So it seems that everything works fine, right? 对嘛，我刚刚说的就是你可以稍微 check 一下 h， 就可以知道到底这是不是大致上 work。h 离0越来越近，代表这是件好事情。OK, good. And then, k equals 3. Okay, and we choose. Let's just say k equals 3. R3 equals 10 times R2. 10 times R2. Yeah, just say it's 100. Okay, and also we update lambda in the same way. So lambda when k equals 3 equals lambda when k equals 2 plus 2 times R3 times h when k equals 2. Okay. Okay. So in this way, we are able to get the numbers, right? I think I'll just directly give you guys the number. Okay. So my lambda 3 is negative 23.484. Okay. And in this way, we are able to calculate x1. Okay, so x1, yeah, I hope you guys can directly calculate x1. So x1 is 10 times R3 minus lambda 3 divided by 28 plus 10 R3. Okay, and that it is it is very close to 1, okay? 0.9956, and x2 is just 4 times that. I'll just directly say it's 4 times x1, okay? And it's actually very close to the real solution, okay? So the exact solution, exact solution is x1 equals 1, x2 equals 4, right? And that's very close to the exact solution, right? So as you can see over here, just within 3 iterations, and lambda k is not very big, right? 100, no, not lambda k, rk, this r value is not very big, and then we can get a pretty good solution, okay? And usually, if you only use the exterior penalty function method to have this kind of accuracy, usually this r value should be like 10 to the 5th power or 10 to the 6th power， 可以吗？就是如果说你纯粹只用 exterior penalty function method， 没有用 Lagrange 的这个写数的话 ，r 可能要增加到10的5次方、10的6次方左右，才有可能有这样的那个准确度。那我刚刚说的 ALM 的最好的它的优点，它就是可以让 r 不需要到那么大。Okay, so I hope in this way you guys can understand what's going on. Okay, so this is the so-called ALM, the combination of Lagrange multiplier with penalty function method. Okay, yeah, are you all right? Okay. Some people need to take a photo. Is there anything to say? Oh yeah. There's just one more thing. Yeah, one more thing I would like to say before taking a break. That is, over here, this example is pretty simple. That is, you have only one constraint, right? But later on, if you have more constraints, then you will need to do basically the same thing for each different lambda, okay? 可以吗？我们刚才只有一个 constraint， 所以只有一个 lambda。之后它如果碰到的问题是有好几个 constraint 的话，你会有不同的 lambda， 每一个 lambda 你都要去把它 update，OK？ So if you have more constraints, then if you have more than one constraint, then you will need to do like basically the same thing for each different lambda. And that is why, over here, in order not to make you guys confused, I put this k index over here, use this parenthesis, because later on you may need to have like lambda when j equals 1, iteration k equals 2, okay, something like that, yeah, for each different lambda. 可以吗？就是之后如果有好几个 constraint 的话，你就这个要做，对于每一个 lambda j 都要做 ，OK。And then basically still just. Oh, and also, when you solve this with a numerical method, yeah, maybe it's even easier, right? Because you just need to plug in your function and plug in the rk and lambda value you have chosen, and let the algorithm solve the minimum for you. Okay? Yeah. But anyways, having this kind of experience, like solving this by hand, is a very good way to understand. Okay? Yeah. let's just take a break first, and we will continue after the break.